So now we have the base of the region is enclosed by the curves y equals x squared and 6 minus x and the y-axis. Now we have cross sections who are perpendicular to the y-axis and they are semicircles. We're going to set up this one, but we're not going to solve it. So let's get a quick sketch of what's going on. So first, our base, we have y equals x squared. It looks like that. And y equals 6 minus x, looks something like this. And the y-axis, which is this line here. So we're actually looking for this shape, or this shaded region here. So the cross sections to that region are perpendicular to the y-axis. So here's a very important thing to pay attention to. If I draw cross sections here, I'm going from this line to the y-axis all the way up until this point, where my two lines intersect. Then from that point down, it switches to be going from x squared to the y-axis. Now mind you, both of these are semicircles. My sad attempt at drawing cross sections. So this problem is a little more elaborate because the radius, or diameter better said, of my semicircles changes after this intersection point from one function to the other. So we are going to have to set up two different integrals here. So the first thing I need to find out is, where do these two functions intersect? So I'll set them equal to each other. X squared equals 6 minus x, x squared plus x minus 6 equals 0, x plus 3, x minus 2 equals 0, x equals negative 3 or 2. So that means they intersect at 2, 4, all right, because 2 squared is 4, and 6 minus 2 is 4. So I know for this one, I am using my, and this is y equals 6. So for this top piece, I am using my linear function, which is y equals 6 minus x. So that means x equals 6 minus y. And for this piece, I know that y equals x squared. So x equals plus or minus square root y. Now this side is positive x's, so that's positive square root y. And this side is negative x's, negative square root y. So I'm not even dealing with the negative square root y part. Okay, so now let's set up my integrals. The first integral for my volume is going to go from 0 to 4 on my y. Now these are semicircles. So remember, semicircles, not volume. The area of a semicircle is pi r squared divided by 2. So it's going to be pi over 2 multiplied by my radius squared dy. Now my radius from 0 to 4 is square root y over 2. So now that's being added to, same thing, pi over 2, integral, now I'm going from 4 to 6, of my radius squared dy. Now what is my radius here? Well, I know my diameter is 6 minus y, but I divide that by 2. And this would be units cubed after I integrate it, but I only wanted you to set up and do not solve that one.